So question 1 on exercise 18D. Find the magnitude and direction of the resultant of the forces. So we have in this question here, we have an angle of 35 degrees sitting on an inclined plane, and there's a particle sitting on this inclined plane. There are three forces acting on it. 42 newtons acting perpendicular to the plane, 53 newtons acting parallel to the plane, and then 60 newtons acting not perpendicular but at an angle towards that perpendicular. Okay, so going to first of all mark on all our forces in a parallel and perpendicular to the plane. So starting just up here, we have 42 that is acting perpendicular to the plane, 53 is acting parallel to the plane, now 60, and as I've said before, using your right angle triangle, 90, 35, so we have to find that missing angle there will be 55. So we know that this one here, if I mark it on there, should be, that makes 90, so that's back to 35. So really whatever angle's down there is going to be the angle in here that we can use this force with. So this one here, if we do it perpendicular, it's going to be 60, and then cos 35, that'll take it down perpendicular. So 60 cos 35, and then parallel to the plane will be 60. The angle's not included, so it's 60 sine 35 over here. 60 sine 35. Now, what we're going to do now is find the resultant force acting along the plane. So I am just doing it in the upwards direction, and what forces do we have now going up there? We have 53 going up. This is obviously going the other way, so minus 60 sine 35. That will give us 18 point, and I've rounded that to 5 n's Newton, and that's acting up the plane, or just following the little arrow that I have indicated there. Okay, the next one there is the resultant force perpendicular to the plane, and that's just a little perpendicular sign to show I'm pointing it up that direction there. Okay, little right angle, little or just to represent perpendicular. So I'm going to go up the ways here. I mean, you could choose to down the ways. I'm just going to go up the plane, parallel to the plane, and then up perpendicular. So it's going to be 42 going up that direction. Take away the other force of 60. Sorry, it should be cos 35 there. So 60 cos 35. On our calculator, if we work that out, we'll get minus 7.15. I have rounded that to 2 decimal places as I did with the one before. And that's going to be, well, it's negative, which means I was going up the ways. Because it's negative means it's actually pulling down more in this direction, okay, because it must have been stronger down here. So that will be 7.15 newtons, and that's acting down the ways. So it's really going perpendicular down the plane, really that direction there. Okay, so what we're going to do now is take these two forces, going up the plane 18.59, and going down the ways perpendicular there is 7.15, and we're going to put those into a little diagram. We're going to draw the resultant forces on that triangle. So draw the resultant forces to find the magnitude and direction. So we're going to do that now. So what have we got? We have 18.59 acting up the plane. So I'm going to draw that in there. 18.59 acting up the plane. And then the 7.15 is acting this perpendicular way here. So after this goes up here, this is going to go down. Just follow the nose to tail of the other one. And what was that one? 7.15. So there we have our parallel one and our perpendicular one acting down. Go back to the start, join those up to give our resultant one, and this creates a right angle. So how do we find our or? It's going to be our Pythagoras theorem. So r squared equals, you can do them in any order, 18.59 squared plus 7.15 squared. So r is going to be the square root of all of that. So r is going to be, it'll be 19.9157 and so on, which we will round to three significant figures, 19.9 newtons. Okay, so now we've got the resultant force. You want to know at what angle it's acting to our parallel, or sorry, to our plane. So I want to find this angle in here, okay, because that will be like along there, like along here. Okay, so we're going to find that angle there. Again, just use the two values you have, don't bother with that one there. And again, it's going to use the opposite and adjacent, so it's just going to be tan. So we're going to find our x. So tan over x is the opposite of 7.15 over 18.59. So we're going to find tan to the minus 1 of that. And yeah, I guess I'll see that, okay. And then that's going to give us an answer of x will equal 21.037 and so on. And we'll round that to 21, well, to 3 significant figures. It's going to be 21.0 degrees. So we've got our angle. So we can write then overall, what have we figured out? You're asking the question, find the magnitude and direction of the resultant of the forces shown below. We got the two forces parallel and perpendicular to the plane. We put them into our diagram and we found the resultant, the magnitude and direction of this resultant force. So we can now say a force of, and what is our force? 19.9 newtons acting at 21 degrees to the plane, and we've found our magnitude and direction of that resultant force. Okay, so you should have tried question 1, have a check through and see that you got it correct, and if you weren't sure you can follow through my method of how to do it there. Okay.